Okay, morning guys. How's everyone? It's okay. It's okay. Good. Are you guys okay at the back? Shh. With the sun on you, you want me to close? Close a little bit? You happy? All right. Shh. Okay, so we continue. Ooh. Guys. I'm getting sick, so don't come near me. We continue with transformations. All right? Now, remember what we were doing yesterday? Just have a look at your notes. We looked at projections onto. The words onto means you project it onto like a wall or something. It's onto. And reflection is in, like a mirror. Yeah? Reflection is in something, okay? So,
can you explain onto
no, I know you're teasing me. You're teasing me. Okay, so we project onto a surface or we reflect in something, like a mirror. So if we say we reflect in the y-axis, it goes through, right? Okay? And so today we're doing, we carry on with transformations, we're doing rotations. So we're going to find a matrix that represents a rotation through a certain angle. So I'm going to start off with how we come about it. So just say we have a point P. Watch this. The point is given by x1, y1. All right? And you want to rotate it through an angle let's call this theta. Now, by convention, and you know this, anti-clockwise, this way, is positive theta, right? We always, when we talk about positive rotation, positive angles, we measure from this side and it's always positive, right? So now we want to move this point and we want to find this new Q point, all right? So this is a point, it's rotated by the angle theta. Now to do this, we're going to do a bit of manipulation, a couple of ideas. So let's just say anti-clockwise is positive rotation. Okay? So we start with saying what is that P in terms of its coordinates. So x1, y1, if we call this distance here r, right? And this angle here, alpha, all right? We get r cos alpha would be your x1 coordinate, and r sine alpha would be your y1 coordinate. Yes? You're all happy with that? Now, let's call this x2, y2. All right? Now, x2, y2, let's see if we can use the same sort of idea. That r will stay the same, right? So the coordinate would be like that. It would be r cos theta plus alpha. Yes? And your y2 coordinate would be r sine theta plus alpha. Is that correct? Right. Now I'm going to break this up. I'm going to break that up using your angle identities. Can you tell me what that is? If I take r and leave it outside. Come, guys. What is cos theta plus alpha? Cos theta cos alpha minus sine theta sine alpha. Right? Let's just multiply that r into that bracket. Sorry, guys. You guys going, ah. Sorry. Let's multiply that into the bracket. So this would be r cos theta cos alpha minus r sine theta sine alpha. And the other one would be, when it's sine, what is it? Cos theta sine alpha minus plus r sine theta cos alpha. Yes? All right, can you see that? Cos theta sine alpha and sine theta cos alpha. All right? Now this is still a matrix. Right? Now we're going to split this up and say that we know that r cos alpha is what? x1. And r sine alpha is what? y1. Okay. So we're going to end up with x1 cos theta minus y1 sine theta. This is y1 and the sine theta. In the same way, we will do that one. R sine alpha is your y1. Y1, and your remainder is cos theta. Plus, have I done this right? Yeah, y, and then r cos alpha is x1, and sine theta. Okay, now I'm going to rearrange the bottom one because I want the x1 to lead. All right? So x1 cos theta, I can't do that, it's a plus sign, right? Minus y1 sine theta, and then x1 sine theta plus y1 cos theta. All right? Now this is equal to, this is a 2-by-1 matrix, right? We can decompose it if we say, I'm going to multiply it like this. So if I had cos theta and minus sine theta here. So it's cos theta times x1 minus sine theta y1, which is this one. And then the other one would be sine theta x1, and then this side would be cos theta y1. All right? Okay, this is your 2 by 2. These are single entries now. Right? And this is a 2 by 1. So if we multiply them together, we get this 2 by 1 matrix. Right? So I've just gone the other way, backwards. All right? So now, given your initial point, and you want to rotate it through the angle theta, you can use this rotation matrix. So basically, it ends up being rotation, and we say theta, which represents the anti-clockwise, spell properly, clockwise, anti-clockwise rotation. It's given by the matrix cos theta minus sine theta and sine theta and then cos theta. All right? So you need to know this. Okay, any questions? Shall we start again? Are you all right? It's okay? Let's just look at it again one more time. You have your point x1, y1, p. That's the one you know. You want to get q, all right? So we said p is made up of these points x1 and y1. And in what we would call I don't want to use the word polar, but in your x1, if we take your r and your alpha, r cos alpha would be your x1, and r sine alpha would be your y1. All right? Are you happy there? Now x2, we can do the same thing, but now your angle is this combined angle, theta plus alpha. Okay. So now we use our, what are they called? Your angle identities, the front of the textbook, which I asked you when we did trig to know them all. And we did a whole lecture on it. So we split this up. So it becomes r cos theta cos alpha minus r sine theta sine alpha. And the bottom one, when it's sine, it's going to be cos theta sine alpha plus sine theta cos alpha. All right? Are you happy? So now we say, but r cos alpha is x1, and r sine alpha is y1. So we replace wherever we see r cos alpha and r sine alpha. Here's a r sine alpha, and here's a r cos alpha. All right? So you get x1 cos theta minus, this is still a 2 by 1 matrix. All right? x1 cos theta minus y1 sine theta. x1 cos theta minus, there's a minus here, r sine alpha is your y1 sine theta, and your r sine alpha, y1 cos theta, plus that. All I did was rearrange it because it's a plus sign. I can do that. And so I could get it like that. And then I decomposed this one, right? So what would give me that? So if I put the two brackets like that, that must be a 2 by 2 times a 2 by 1 to give you a 2 by 1. So it would be cos x1 cos theta minus y1 sine theta, gives you that entry, and x1 sine theta plus y1 cos theta. Okay? So basically, if we have our old point, this is the transformation that rotates it to get our, remember this was still x2, y2. Remember that. We were here. There's equal signs all the way. All right? Okay, so now we know your clockwise rotation, the matrix that represents the anti-clockwise rotation. Our clockwise rotation then will be represented by minus theta. Right? And then that, you say cos of minus theta, but it's even. Right? Is cos theta even? So cos of minus theta is simply cos theta minus sine of minus theta is just sine theta because it's odd. Right? Am I going too fast? Must I write it out one more time? So it's cos of minus theta, and it's minus sine of minus theta, and that would be sine of minus theta, and this would be cos of minus theta. And so then, simplified, this becomes cos theta, because it's even. These two are even, right? And minus sine of minus theta is simply sine theta, and that would become minus sine theta because it's odd. All right, so this is the one that represents the clockwise rotation. So when you're using this, you don't need to put in minus theta because we already did it here. So it's up to you which one you want to remember. Okay, so just remind yourself this is the clockwise rotation. Okay, now we're going to do some examples using transformations. Let A and B that be matrices that represent respectively a reflection in the y-axis in R2 in 2 dimensions, and a clockwise rotation of pi by 4 radians about the origin. Okay? So part A says write down, it's a write down A and B. Doesn't mean you must just write A and B. You must write out what those matrices are. Okay? And part B, find matrix M that represents this reflection and then the rotation. Okay, part A is quite easy. What is A? The matrix A. Anybody? It is a reflection in the y-axis. So x changes. Is that correct? Come on, we did this yesterday in class. Have a look at your notes at the back, one page back, 2 pages back. What is B now? So it is a clockwise rotation through pi by 4. So what I like to remember is, if it's a anti-clockwise, my negative sign is in the top right corner. And if it's a clockwise rotation, my negative sign is in the bottom left corner. It's just one of the things I use. You can use anything you want, but that's one of the things I use. So it's a clockwise rotation, so it's going to be cos pi by 4 sine pi by 4 minus sine pi by 4 and cos pi by 4, which is, what is cos pi by 4? 1 over root 2, right? You can say root 2 over 2 is fine. It's the same thing. 1 over root 2 and sine of pi by 4 is the same, isn't it? Your lovely triangles that you need to know forever. 1, 1, root 2. That's pi by 4, pi by 4. Are you happy? So 1 over root 2, they're all, so then I could just put in that matrix like that. Right? Remember, you can take out a scalar, right? Because this was 1 over root 2, 1 over root 2, minus 1 over root 2, and 1 over root 2. I could take out the scalar, and I'm left with that. All right? So we got A and B. We just wrote it down. There was hardly any calculation done. Right? No brain cells were used. I'm joking. Stop being dark. Stop being dark. Stop being dark. All right. Shh. Okay, now the second part is the interesting part. Find matrix M. Okay, so it's a matrix that represents a new operation. The first operation was a reflection. So we took something, right? We had it here, P here. We reflected it first in the y-axis, and then we rotated it clockwise by 45 degrees, okay? All right, so we're trying to find out what single matrix represents that operation. Now, we can do it graphically, but now we're going to show you linear algebraically. Okay? So, M, right, is given by, if we do the first operation, right, then this would be the matrix A, would be minus 1, 0, 0, minus 1, right? And we'd get an answer, which would be a, what is the answer for this? a 2 by 1, my answer, right? So what is a 2 by 1? It's a new point, right? Then we multiply it by another one, which is our 1 over root 2 outside. That's 1, 1, minus 1, and 1. And then we'd get, again, it's a 2 by 2 multiplied by a 2 by 1. We'd also get a 2 by 1. So we'd get a new point. Hang on, hang on. So your matrix, really, that represents one single operation is that. Okay, that multiplication. So we multiplied because we know how to multiply matrices. And so it becomes, I'll leave the scalar out. That's minus 1, 0, minus 1, plus 1, and minus 1. That's, oh, sorry, thank you. That changes everything. Okay, let's just check it. That's minus 1. That's correct. That's 1. That's plus 1. And that's 1 again. Okay. Is everything all right? So basically, the idea is when we write out our matrix multiplication, your first operation is on the right. Then your second operation is here, so that you multiply it, you'd get your single matrix representing one single operation that you would apply to your old value. All right? Question, there was one. Makara first? It's fine. Oh, okay, all right.
What does new matrices, what does it represent? Reflection?
It's both. So this new matrix represents both things in one, both operations in one. Okay? All right, are you happy? Yeah?
What's the order of which you multiply your matrices? It doesn't matter.
Yes.
So the first would be an A.
Shh. I tried to explain it. Guys. How do you know why the order is like this? Whatever you do first. Shh. Okay, guys. One more. Okay, let me listen to your question and then maybe it'll. What's your question?
I don't understand what you are saying, because you are saying that we will get that from the question, but now the question says reflect and then rotate. But here you started with the rotation.
I tried to show you with putting that old point there. So what happens first, right? Guys, one more time. We've got our old point. 1, 1, right? We apply the what did it do first? It reflected first in the y-axis. We apply that. We get a new value, which we then multiply by the rotation. 1 minus 1, 1. Can you see what we've done? We've put the first one here, and then this one here. So if I brought this down as my value, if I brought that down, does that make sense now? Why we put A first on the right-hand side, doesn't matter what name it is, But the first operation that you do, you put it on the right-hand side because you're going to do that one first. Then the new point, you're going to do this one first. If we had changed the order, that means we would have done the rotation first and then the reflection in the y-axis, which would give you a wrong answer. Right? The question is saying first a reflection in the y-axis and then a clockwise rotation about the origin. Okay, so order, so your M then would be the single matrix here. We multiply these two together, right? The single matrix that when applied to that old point gets you a new point.
Okay, there, on your answer, where is that X1 and Y1?
X1 and Y1. This is, how could you say this? With matrix multiplication, this represents a single operation. You have to look at me when I'm talking to you. You ask the question, right? This represents one matrix, a single matrix that represents both operations. So remember I said we are first reflecting and then rotating by an angle theta. Clockwise, sorry, went the other way. It is a clockwise rotation. Clockwise rotation, so you'd get somewhere there. Okay? So this is like two operations. We are now putting it in one operation that is one single matrix, which we then apply your old point to. All right, so when we talk about matrix multiplication, if you've got A, B, and C, right, what we've done is we've said, right? Doesn't matter. So all we're doing is we're finding one single matrix that represents both operations. Okay. And then we would apply. So if the question is saying, now apply, where does the point 1, 1, 1 go to? 1, 1 go to. So let's make a part C to this. Determine Q, that's x2, y2, that represents, that determine Q, the new point, how can I ask this question? Determine Q that where does the point 1, 1 map to? All right? So then, using this above, using B, using M. All right? Using M, where does the point 1, 1 map to? So what did we find as M? M was, so your new point is going to be given by M times your old point. So it's 1 over root 2, and it's minus 1, 1, 1, and 1. That represents, this is our new matrix M. This is our old point. And we get a new point. All right. You guys know how to multiply. You can finish that. Okay. You guys, who's not understanding? Because there's murmurs, but I know murmurs mean that you've understood and now you've moved on and you're still chatting. And there's murmurs when you don't understand. So I need to decipher which murmurs are which. Any questions? Atan Kosi.
Like it's me, what? Like does the word that represents me?
Yes. Represent. So what is a matrix represent?
It's what it does.
Yeah, what it does. Okay? Any other questions? So, from this learning, when performing transformations, place the first operation on the utmost right. Okay? So guys, here, if you just listen to me 1 second, just say we were doing a clockwise rotation followed by a projection into the x-axis, onto the x-axis, and then followed by a reflection, a rotation anti-clockwise. So I said rotation, clockwise, projection on the x-axis, and then a rotation anti-clockwise, right? So let's write it out here. If A is equal to rotation, what did I say, clockwise, B is your projection onto your x-axis, and C is your rotation anti-clockwise. You did those operations to one thing. Determine M, a single matrix that represents that whole operation. What would it be? So then M, if we did this, so our M, when we're finding it, we do like that. Okay? If we started off with this, this, and then this, then you put your first operation here, second operation here, and then your third operation here. And then you multiplied to get the single one. Okay? So the order you place these things is important, because basically you did this first, then you found a new point, then you did this first, then you found a new point, and then you did that first. Because you're always placing your 2 by 2 matrix on the left of your point, isn't it? You can't do it the other way around. Can you multiply x1, y1 by a matrix? Can you do that? No, because this is a 2 by 1 and this is a 2 by 2. 1 and 2 don't equal. The number of columns must equal, in the first one must equal the rows in the second one. Yes? Okay.
Can there be a rotation of also z-axis?
Yes, you will learn about that in second year. Yeah. Okay? All right, so we're just doing shh. We will continue with 3D stuff next semester, next year. Well, you will, not me. I'll be repeating myself here. Okay, shh. All right, the last thing I want to do, reflection about the line y equals mx. Can I erase this? Let me do it here. Let me start here. Okay, so reflection about y, about the line y equals mx. All right. So this one has this idea that we're going to do a couple of operations to get to this single matrix that represents the matrix that does that. Okay? So basically, when we start about trying to get the reflection in the line y equals mx, we start with the idea that this is our line y equals mx. I've got a point P here, which I then want to reflect in that line to get Q, right? That's what I want, okay? How do I do that? I'm going to do it this way. I'm going to take, all I've got is P, and I've got that line. I don't have Q. So I'm going to take P first and the line and rotate it. I'm going to rotate it through this angle theta. All right? Now, so that we're going to rotate. This direction is clockwise, so we're going to do a clockwise rotation. So we move the whole space. We keep the axis as is, but we're moving the space. So we're moving the line and the point. What do we get? What do we get? We get this being the y equals mx and the point here. So we've moved the line and the point. Right? So we've moved that whole space, rotated it clockwise, and we're there now. Right? Then I'm going to reflect it in the x-axis. All right? When we reflect it here, we get this point here. All right? So this was our point P. This is our new point Q. Let's call it P1 and Q1. Right? So listen one more time. We took the line and the point, we rotated it clockwise. Then we reflected that point in the x-axis to get Q1. Now I rotate it back by the same angle. By the same angle, I do then I rotate it anti-clockwise by the same angle. So this is still your line y equals mx. And we move the P and the Q. So now we have the Q. Right? So 3 operations can give us what this reflection y equals mx is. All right? So those 3 operations, we write